So I'm Samarth from Spina Research Labs Private Limited, and this this talk is about spying on your corporate rivals using stochastic processes, artificial intelligence, machine learning, and big data. And I'll briefly discuss about some problems in corona research I have been working on. So just to introduce the lab, it's just a little more than 1 year old company. It's a private scientific research company. The talk that I'll be talking about, that I'll be giving today, is mainly from the technology cracking program of the company, where people approach us to find out what is the technology behind a certain startup that is there in US or wherever, or the technology behind some product or service that some other rival company is offering, and they want, so we can put together a team of experts, international team of experts, to work on finding out what's the technology behind it, making an assessment, can it be substantially improved so that you can compete with them by launching a much more improved thing, and also making an assessment as to how much resources will be required to do that, so that the client can then decide whether he wants to go further or not. We have been involved in artificial intelligence, machine learning, data analytics, bioinformatics, statistics, satellite technology so far, negotiating laboratory access with other organizations for vaccine development. We have in-house research projects as well. Earlier, we used to offer trainings. Actually, the website right now is an old website. You'll soon see a overhauled website, maybe 1 week from now, which will have more recent stuff. Any PhD students, postdocs, or anyone else interested in working on live industrial problems, you are welcome to get in touch. And most importantly, come visit us. We are in Gurgaon, Cyber City. We'll be happy to host you. So the question that our client posed is, how does www.similarweb.com work? Let me show you the website itself live. So this website, you give any website's address here, and they will tell you, here I have given IIT Delhi website address, just for an example, and they have given me the total number of visits that this website gets, various other statistics, pages per visits, and so on. In this, for the purpose of this talk, just for illustration, we'll discuss the total number of visitors per 3 months or whatever. So how come this website, similarweb.com, find out about any website in the world? What are the number of visitors there? No website will tell you any statistics. No company will want to tell you any statistics about where they are getting visitors from, what are the area, what are the product pages that are more popular, which are less popular. Nobody would want to give you this data. How does similarweb.com find it out? Was the question that our client posed to us. The other question is that, can the technology be substantially improved? So then the client can think of launching his own website to compete with similarweb.com. And the most important question, the most important milestone that we want to get to quickest in such projects is that, what are the resources required? How much money will be required? How much time, effort? Is there some niche expertise required that is not easily available in the country where the client is from, and so on? So coming to similarweb.com, I'll illustrate this. We have done this for various technologies, 2-3 other technologies as well, 2-3 other projects as well so far, and some are ongoing. But let me illustrate you through the similarweb.com example. So how do you find out how many visitors any website is getting? Represent the entire internet as a directed graph. So first I'll tell you the toy model solution, then I'll tell you the more real life solution that one would actually execute. Toy model gives the principles. Represent the internet as a directed graph. Each node is a website. Each arrow represents a link from a website to another website. So that if you click this link on website B, you'll go to website N. Then there is an arrow from B to N. And this model is used by Google's PageRank paper original PageRank paper. It's called random surfer model. You assume that each person browsing the web does move through the web randomly. So if he is on website B and there are 2 links coming out of website B, he will click either of them with equal probability in the next transition. And if there are 5 links coming out, then he'll click any of those 5 links with equal probability of 0.2, and go to the respective 5 websites with equal probability. And what one can do in this toy model is to iterate this lot of times, start with some random distribution, iterate this lots of times, and finally you'll get a steady state distribution of the surfers on the web, internet. If you know the total number of people on the internet by some estimate, guess or something, you can multiply by the respective probabilities and get the total number of people on various websites. You can get the total number of visitors on various websites. So this is the toy model solution. What I just explained intuitively, one can just do it mathematically. So actually it's a long list of equations. I'll just point out 2 important ones. So if you are at a website V with probability P, in the next transition, you will go, if there are n V links coming out of website V, you'll go to the UH website with probability 1 by NV, provided U is one of the U is pointed to from one of the outlinks from V. There are some additional complications. You need some source term here because some of the surfers will get trapped in some websites which don't have an outlink and so on. The iteration that I said, we can just formulate it as a matrix multiplication here. There are lots of other equations which basically take care of the boundary conditions, and some adjustments for the source thing are required. So if we are convinced of this, basically if you know the intuition, one can just write down the equation. Let's not bother about the mathematics. That can be taken care of. So if the random surfer model converges, it's equivalent to getting the steady state solution of the visitors on the internet on this directed graph. And then you just multiply by the total number of random surfers, you get the actual numbers from the probability. So let me briefly outline the real solution, the more detailed solution. One collects a lot of data about internet user behavior from as many sources as possible. You might place cookies in various people's browsers. You might pay some websites who have placed their cookies. Let's say a big newspaper website would have placed cookies in their users, in their logged in users' browsers and so on. You might buy data from them and things like that. And then sometimes some data might be available from internet service providers, once in a while, some kind of data, and things like that. And then you fit giant regression models. Now, for normalization purpose, just like we normalized here for n, the number of users, here some more normalization will be required. Basically, you need some actual numbers for some of the websites. That you can obtain by paying some of the websites to give you the actual numbers, actual data. And this is the major way. Then there are other complications also. There is something called graph machine learning. It's recently emerging. You might use models from there. And then you just fit these giant regression models and find it out. So the numbers that can be quoted are actually regression models from user behavior. So if you see the acquisition patterns by SimilarWeb.com, you can see that perhaps they are trying to acquire companies in a way that they might be obtaining more mobile data and user data. So the objective is to earliest possible assess how much resources will be required. In this case, that assessment was not too difficult. We quickly, as we started some analysis, it was clear that millions of dollars will be required to acquire just some basic data. And the client decided not to go ahead with starting his own service to compete with them. In the end, let me just give you a flavor of another in-house research project that has been going on, that I have been working on. So basically, there are various Corona research papers that I have been reading and analyzing the data of that. and trying to do rigorous data analysis of that. In one of the important papers here, there is a claim by Tarhimi et al. And so on. There is a claim that nosocomial superinfection is a diagnosis in the case of corona patient. Nosocomial means it's a hospital-acquired infection. Superinfection means that he was already suffering from corona, one of the strains, and another strain of corona he got infected by it.
So, Dr. Chandra, you have got 2 more minutes left.
Okay, thank you. So the starting point of the investigation was that data in the tables was not matching some of the statements in the text of the paper. That was the starting point of the investigation. Basically, the dimer covering problem that we have in statistical physics, statistical mechanics. So you can have a k-mer covering version of it, and NGS data, next gen sequencing data. How do you by sequencing short reads of DNA or RNA, you can then reconstruct an entire sequence. So basically, some of the data in the table was not matching the statements in the text. And then I had to get into the proper patient case history of the patient to really figure out what's going on. And it turned out, and matching the case history with various medical research papers, it turned out that it's actually a case of evolution of a strain, mutant strain of coronavirus 2, SARS coronavirus 2, with as many as 7 mutations in an immunocompromised patient. It's not a case of hospital-acquired infection, superinfection. The new strain that is seen has been evolved within the patient. And it throws light on the mechanism for the generation of new variants. So I just submitted this to the journal. And finally, let me conclude by saying that I hope that the diversity of problems mentioned here in this talk reflects the great freedom that Muskan sir and Deepak used to give to all of their PhD students, which has led some of us to explore diverse area in science and technology. And lastly, let me thank Tridib, Shakuntala, and Kavita for connecting with me with all of you again. Thank you.
Thank you, Dr. Samad Chandra, for introducing our company and for your very informative presentation as well. So all the talks are completed. So before concluding the session, let's thank all the speakers of the session